Hey, welcome to this video. In this video, we will see what linear regression is. Linear regression is a supervised learning model. In supervised learning, we have labeled data like this. Here we have a housing prices data set in which we have living area for every house, number of bedrooms in the house, and the corresponding price of the house. So, given this data, we have to predict the prices of other houses in the vicinity that are not present in the data set. So how do we do that? Let's assume if we plot this housing prices data, it looks somewhat like this. Here we have living area on the x-axis and price on the y-axis. We're not considering bedrooms for now. Now, given this data, we have to predict the price of other houses. For example, if the area of a house is 5,000 square feet, we should be able to determine the price of this house. But if we look at this data, it's impossible us to predict the price of this house because we have to manually find patterns in this data. And if the data sets are large, it will be impossible for us to predict the price in such a way. In linear regression, what we do is we draw a line through the data in such a way that every data point is closer to this line. That means if all these crosses represent the data points in the data set, that means the perpendicular distances of every data point from this line is small. If I draw a line like this, you can see these data points are closer to this line, but these data points are far from the line. And if a line is drawn like this, then the data points here are closer to this line than these data points. Now what we have to do is we have to find the optimal position for this line. How do we do that? In order to find the optimal position, we need to move this line and place it in such a way that the perpendicular distances to every data point is minimum. But how do we move this line? We know that in mathematics, the equation of a straight line is given by y equals mx plus c, while m is the slope of the line, that is the angle that a line makes with x-axis, and c is the intercept, that is the distance from origin to the point where the line cuts the y-axis or intersects the y-axis, that is this distance. That means this is the c-intercept. If we increase or decrease c, we can translate this line along y-axis, and if we change this angle, that is the slope, we can rotate this line. That means by changing m and c, we can place this line in our desired position. And by drawing this line through the data, now we have something that we can use to predict the price of the houses. We can call this line as our model. Now if we want to find the price of the house with a living area of 5,000 square feet, we can draw a line perpendicular to the x-axis from this point and see the corresponding value of price on the y-axis, and like this we can predict the value of other houses. The price that this data point will give will not be accurate, but it will be close to the actual value. Suppose if we try to find the predicted price of this data point. This is the actual price, but if we try to find the predicted price using our model, we'll get a price corresponding to this point. This will be our predicted price, but it's slightly off from the actual price. That means this line will give us the predicted prices of the houses with less errors. As you can see, this is a linear equation, and hence the name linear regression, because the relationship is linear and the predicted prices are continuous. To write this in a machine learning way, in machine learning we call this model as hypothesis, and is denoted by h theta of x, whereas theta are the parameters and x are the features or input variables. In our case, living area and number of bedrooms. We can write our hypothesis as theta naught plus theta 1 x1 plus theta 2 x2. x2 is the number of bedrooms, x1 is the living area. To make this equation more consistent, we can write this as h theta of x equals theta naught x naught plus theta 1 x1 plus theta 2 x2, so on up to number of features that we have in our data set. Here we have only two features, that's why we are using x1 and x2. Now we have added another feature x naught here, we call this as a dummy feature. This is just to make the equation consistent, and we say x naught equals 1, so that if we use the value of x naught here, the original hypothesis is not affected. We can write the hypothesis like this as well. Summation j goes from 0 to 2 theta j xj. Now that we have finalized our hypothesis as a linear function, the only things that are unknown here are the parameters theta naught, theta 1 and theta 2. And if you remember, by changing these parameters, we will be able to find the optimal position for this line. In the next video, we will see how we will find the parameters theta naught, theta 1 and theta 2 such that the line fits perfectly to the data. Thank you.